Welcome back guys to our channel. Today we will learn about Multisim's instrument panel. Remember we spoke about rich collection of simulation tools available in Multisim? Those are actually very useful to diagnose and learn about circuits. There are analog and digital instruments. In this video we will talk about only important analog instruments such as multimeter, wattmeter, oscilloscope and measurement probe. Let's start with drawing a resistive circuit to simplify the discussion. Using the multimeter, we will measure equivalent resistance across these points. Pressing this button or F5, we can start simulation and the tools start operating. Oh, we got an error. See the error? We forgot about grounding the circuit, one of the basic mistakes we do in early days of learning. Let's ground the circuit and run. Here comes the output. I think the result is as per theoretical calculation. Try yourself and comment below if you find something wrong in this measurement. As a multimeter, it measures voltage and current as well. Let's apply a DC source and check the voltage across R2. Make sure you measure DC voltage only. If you measure AC voltage by mistake, for this circuit you will get nothing. But if we replace the DC source by an AC source and measure the AC voltage, we get correct answer. Now coming back to the DC circuit, if you measure the current keeping the multimeter parallel to R2, we get 6 mA. I'll leave it to you to explain why it is showing 6 mA for this measurement configuration. To actually measure the current, the multimeter must be connected in series, like an ammeter. For any change in the circuit, the simulation must be stopped first. Here we get the correct measurement value. Now if you like to measure power consumption, you can directly use the wattmeter. It measures voltage and current simultaneously and calculate the power consumption. So to measure power consumption of R2, connect voltage probe parallel and current probe in series and run the program. As it is a DC circuit and resistive load, the power is current multiplied with voltage drop. So correctly, it's showing 60 mW. But the actual use of wattmeter comes when you have an AC circuit and reactive load, where the power factor comes into play. For example, let's have a simple RC circuit and measure power consumption by the system. Of course, we have to add an AC voltage source, say 100 volt 50 Hz for convenience of calculation. So let's rewire the circuit and run again. See, we have measured power as about 10 mW. Now let's use a measurement probe in this circuit and run again. A probe is a convenient tool to check node voltage and current. A probe measures the node voltage with respect to the ground potential. So in this case, showing voltage across the whole RC network. And it measures current in the direction of the arrow. Take the RMS voltage and the RMS current from the measurement and multiply with power factor. See, we're getting the real power consumed by the circuit and matching with the wattmeter measurement. But why the power factor is less than 1? Well, power factor depends on phase shift of current from the voltage. It happens with reactive loads such as capacitor or inductor. Let's see the effect using an oscilloscope. This is a 2-channel oscilloscope, but it only can measure voltage. So, to show the voltage, connect one channel across the system. And to show current, connect other channel across R1, as current in the system is proportional to the voltage across R1. Here we go. The window looks similar to grapher window, but there are some differences. Oscilloscope is better to visualize slow-moving signals. It should be used for continuous simulation, while grapher is more precise and convenient for fast transient and of course other specific type of simulations that we have already discussed in our previous video. Let's mark the nets with different colors before running the simulation. It will help when we'll be using the oscilloscope. In the display, red is the voltage and green is the current signal. If we freeze and look closely, we can see the current is leading as estimated for capacitive load. Now let's reduce the circuit reactance by increasing the value of C1. See, now the power factor has improved and the real power consumption has increased. Let's check the phases in oscilloscope. See, the voltage and current are now having smaller phase difference. Now let's find out what happens if we use an inductor. we replace the capacitor by an inductor. First use a small inductance, say 1 Henry, and check the phase change. See, the current is lagging now. Note the real power and the power factor. Now if we increase the reactance by increasing the inductance value, as expected, power factor has reduced, real power consumption reduced, and the phase shift has increased. Using the measurement probe, recalculate the real power consumption. That is same as measured by the wattmeter. So that's it for today. In the next video, we will learn about the digital tools. Till then, have a nice time practicing Multisim. Thank you guys.